right, guys, welcome again. We've got 1.2. Today's a short day, so I'm going to do this, and if we have time, then we'll do the questions. If not, then we can always do them tomorrow. But I want to make sure I get the lesson out in that framework so that we don't fall behind. Today, our focus is on the basics of functions, function sand. We need a space up there. Functions and their graphs. There's going to be a couple things that we're going to talk about, actually quite a few things, so hopefully we get through them all. Domain range. Determine whether a relation is a function. Determine whether an equation represents a function. Evaluating a function. Graphing functions by plotting points, which is the primitive way, right? That's way back when. Using the vertical line test. Obtaining information about functions from its graphs. Identifying the domain and range of a function from its graph. Identifying the intercepts from a function's graph. So we've got a big, hearty agenda. Hopefully some of these things aren't too difficult. You've already talked about those, so maybe we can, if there are some questions, we can ask those. Make sure that we clear things up. Thanks for not having your earbuds in and closed laptops so that you're not doing work while I'm trying to teach you this. Thank you very mucho. Can I change the slide?
Yeah.
We're going to move on then. And then we'll come back up again, so hopefully. Definition of a relationship. A relation is any set of ordered pairs. The set of all first components of the ordered pair is called the domain, and then the second part is called the range. Let's talk about a relation. I really like this story. When I heard this story when I was in college, it really made sense to me. And I'm not out trying to offend anybody. This is the way I heard the story. Okay? And it really clicked. So talking about relations, I'm talking about relationships between boys and girls. And he said, think about functions as a relationship between boys and girls. And here's the one rule in order for a function or a relation to be a function, or a relation to function, if you're thinking about it relationship-wise. Here's the one rule. Every guy can only be with one girl.
Girls can have more than one guy.
That's fine.
We didn't say any other rules. The only rule is every guy can only be with one girl. And that was the rule in order for a relation to function. So if you heard that before, then good. It helps. Later on, did I?
Yeah.
Then we're done. Let's go to the next. No, I'm just kidding. So keep that in mind then, okay? Yeah, later on there will be these one-to-one functions we're talking about, where of course we got monogamous relationships, one guy, one girl, one guy type thing. But right now we're talking about relations here. All right? So let's carry on. In this case, they're asking us to find the domain. Anyone have a problem with the domain being every first value here? Every x? Domain is just all the x's. So I would say the domain is 0, 10, 20, 30, and 40 in this case. Can I make any other conclusions about the domain? I can see that it's going up. But can I include any other domain parts in there?
No.
Could I add like maybe 5 and 4.2? No, because I don't even know if it's part of it, right? But according to what I have, that's my domain. And of course, the second part would be the range. Cool beans. Let's move on. Same thing. Is this a function? Well, I only have to worry about the guys, right? So here's what I'll do, is I'll go through and I'll scan all the x's. Do any of them repeat themselves? No. If they do not repeat, then there's no possibility that they're going to be matched up with a different y. So at this point, we're good. We call it a function and we move on. Cool?
Yeah, the number 5 goes.
We're not worried about 5. We're only worried about the guys, right? Yeah, someone wanted to point out, hey, we got a player. Play on, player. But you know what? We're not worried about the y. We're only worried about x. All right, cool. Moving on. Determine whether this is a function or not.
Yes.
This is not a function. Anybody recognize the equation?
Yes.
What is it?
It's a
It's a circle. Circles! In these conic sections at the end of the school year. Yeah, that's a circle. And obviously it's going to fail the... It's going to fail the what test? The vertical line test. Yeah, if I pick this guy right here, x number 2, it's going to have a girl up here on the north side and a girl down here on the south side. Not okay. Cheating. So not a function.
One on the west side.
The other thing, though, if we don't see it graphically, if we were going to solve this, we've got y squared is equal to 1 minus x squared, right?
Yeah.
And of course, I'm going to take the square root of this, which means y is going to be equal to plus minus the square root of all that business in there, which means that if I do put some value in there, guess what's going to happen? I'm going to have a positive and a negative version of y, which means that's not going to be okay. Not going to be okay. So it even fails it algebraically. Okay, so be able to look at those that way. If you can't look at the graph. Questions on this one? All right, cool. Moving on. Functions and function notation. F of x or f at x. It's the value of the function f at x equals blah. Okay? Questions on that? I usually say f of x. I'm going to try to say more of f at x. Just because it sounds cool. Because it sounds different. I'm going to move on. So, evaluating functions. Before, they used to give us an equation and say, hey, you know what? Figure out if x is equal to that. You guys remember that? And then you take that little x and you plug it in for every x and you figure out what y is. Well, here's the equivalent. Here's the equivalent. They want us to evaluate f at x equals -5. So, same as before, all the x's become a -5. So I've got 25 plus 10 plus 7. So I get 40 deuce. And of course I should write it as f at -5 is equal to 42 because that is a lot of information. I've got an x value and I have a y value all in one function there. Questions on evaluating these? So, oh, that's a no. I got one.
Wow. Where did it go?
I'm just kidding. That don't even work.
That's
That's for the other one. That would have been cool though. I actually got 3. Look, that's what I juggle up here.
It's fun.
Where did it go?
Where did it go?
The graph of a function is ordered pairs. I think I said that yesterday when we were talking about graphs, right? And I said, hey, you know what? We have an ordered pair and we graph it. Right? So there's a graph of, what is it, 1, 1? The graph of a function is just all of these. A lot of them. A bunch of them on top of each other. And it looks like a curve of some sort. Or a line. Vertical line test. Vertical line test is a visual of pretty much that one-to-one, or sorry, the one guy for every one x for every one y rule. So here's it passes, no pass it, no pass it. Anything else I need to say on that?
No.
Okay, cool. And later on when you do the one-to-one functions, guess what other rule will come into play? The horizontal line test. Moving on. Analyzing functions. In this case, they have us finding f of 5. I've got a picture. Well, I can see the function. I see that there's 5. I'm going to go up to here. What's the y value? 400. Guess what? I'm done. I've evaluated the function at 5. Questions on how I did that?
Makes sense.
This is so difficult. We're good? Moving on. Finding domain from its graph and range from its graph. This is kind of nice that we started with something simple like this so that you can actually see what we're talking about. When we're talking about domain, all we care about are what values of x are there. So in the domain, we're going to say that x is an element of all the numbers from, let's see, where does x start? It starts here, doesn't it?
Yeah.
And it goes all the way to here?
Yeah.
Any other x values?
No.
That is the only range, right? That means that x is going to be less than or equal to 2, but greater than or equal to -2, and there is my domain.
Yeah. And we won.
Not bad. Why? Questions on finding domain? Nope. All right, cool. Let's go range. Range. Y is an element of, let's see here. We're going to start here at 0. That's the smallest y it can be, right?
Yeah.
And we're going to go up all the way up to now, which is 3.
Yep.
So, less than or equal to 3, greater than or equal to 0. And there's domain, there's range. So that's kind of what we're doing with all of them. But sometimes they just have to go off into infinity, don't they? So then instead of having an endpoint, we just say it goes off to infinity. Cool? Questions on domain range from graph? No, sure. I like that. You try. You try. And then I call you.
Excuse me, sir. Then why did you look at my
Hot
face?
Cheetos. Cheetos. Have you ever had Cheetos with chamoy?
Yes.
No. My wife, her favorite is the Tostitos. She'll do the Tostitos, but she goes in some chaca chaca and some cacahuates japonés.
Oh,
And,
Did she make it by herself?
yeah, at home.
oh, I didn't realize.
There's
We're doing domain and range.
go by the Sparkin. That's so good.
Basura.
You don't like that taste?
It's so good.
Why would I can have it at home? Here, she charged me 3 times what it cost me to make.
Not all of us have to.
Touche. You need to get yourself one of those wipes.
I'm working on it.
Right now, when we're done, I'll tell you about the county store you can go to get the good stuff. It is in the valley, though.
And ooh,
We just found it.
Cheetos with
Delicioso!
chamoy, and they put papaya, mango.
Chamoy. All right, let's see. Did this? Oh. It's gonna take a little bit for me to call somebody. Gunner, what'd you get for domain?
I do domain, I have range. I finished. I history the range.
Sounds good to me.
Uh,
What's the range?
0 is less than or equal to
Y is an element.
0 less than or equal to.
Less than or equal to.
No, that's just normal, isn't it?
Is normal.
Yeah, because it's an open circle.
Oh, on this side?
Yeah.
You just want less than?
Yeah.
Okay. So Y is less than
2.
2,
And then
but
equal to 0 or less than or greater than
greater than
equal to 0.
equal to 0.
Yeah, isn't it?
So we want the Y values, right? So I want to go here. So I do know it goes from here, right? Open circle.
Yeah.
It goes all the way down to there,
Okay.
right? So where do I want to be my lowest value?
Negative 1.
-1. Boom chakalaka. Good job. Ah. Okay. So there's that one. And then still loading. Tara. Give me the domain. Finish it up for me, please.
So x is any element. Hold on. Less than negative or -2, and then less than. Yeah. Or what do you mean that? And then I wrote it backwards. Hold on. Okay, so x is greater than or equal to, or greater than -2,
Okay.
and then
The less than,
less than 1.
like that. Double check my work that I wrote, what you said.
Hold on. Here's a little line under before 1.
So less than equal to 1. Can I get a second?
See,
Can I get a third? Boom, boom. There we go. Let's move on. Good job, guys. Finding x-intercepts. Let's do y-intercept first because there's only one way. It's so easy. If we want the y-intercept, what do? We make
X0.
x0, right? So in order to find this guy, you're going to make x0. And usually we call that 0 comma b, but that's just a fact, right? Now, the same is true the other way around. If we want to find the x-intercepts, we make y0. Hence, that's why we always take our functions, blah, 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 and we make them equal 0, right? And then we go through and we factor all that business, but they're always equal to how much? 0 because we're making the x value, sorry, the y value equals 0. So it's going to be as simple as, we'll call it x comma 0, okay? So that's all we're really doing. So look, it's a graph.
Wow.
So nice, yeah? What degree is this function? 3. 3.
Cubic. Oh yeah.
1 slope change, 2 slope change, 3 slope change. Also, because it has 3 zeros, that's a pretty easy giveaway, right? So, do I really need to talk about how to find those zeros on this picture? What you're going to want to learn to do is find these zeros, because they won't always give you a picture, but on your graph with a calculator. Okay. All right, so let's see if we can do that. I'm out of slides. No, I'm done.